Hello everyone. In this video, we are going to discuss about exercise question 6.2 from the chapter 6 Systems of Particles and Rotational Motion, class 11 Physics. You see, the question is, in the HCl molecule, that is hydrogen chloride molecule, the separation between the nuclei of the two atoms is about 1.27 angstrom. That is, the distance of separation between hydrogen atom and chlorine atom is 1.27 angstrom. That is, if this is the hydrogen atom and this one is the chlorine atom, then from here to here, that is the distance of separation between hydrogen and chlorine atom, this is equal to 1.27 angstrom. And you see, angstrom, 1 angstrom is actually equal to 10 raised to minus 10 meter. So 1.27 angstrom will be equal to 1.27 into 10 raised to minus 10 meter. Okay, find the approximate location of the center of mass of the molecule given that a chlorine atom is about 35.5 times as massive as a hydrogen atom and nearly all the mass of an atom is concentrated in its nucleus. That is, if we consider the mass of the hydrogen atom as small letter m, then mass of the chlorine atom will be 35.5 times as massive as hydrogen atom. So, mass of chlorine atom will be 35.5 times mass of hydrogen atom, that is 35.5 m. Okay. Then what we want to find out? We want to find out the approximate location of the center of mass of this HCl molecule. So here you see, this we can consider as a one-dimensional case because you see both the hydrogen and chlorine atom, they are lying along a straight line. So if we consider this one as the x-axis, then we can consider both the atoms are lying on the x-axis. Okay, so this is the case of one dimension. So in one dimension, what is the equation to find out the center of mass of a system of particles? This is a system of two particles. So the equation to get the center of mass of a system of two particles, that is the position coordinate of that center of mass x will be equal to m1 x1 plus m2 x2 divided by m1 plus m2. So here let us consider m1 as, that is mass of the first particle. Let us consider first particle as hydrogen, then its mass is m. Okay, what about m2? m2 is the mass of the second particle. So mass of the chlorine atom here, which is equal to 35.5 m. Okay, and you see, let us consider the hydrogen atom is at the origin of this coordinate system. Then x1, what is x1? x1 is the distance to the first atom from the origin. So hydrogen atom is at the origin, we considered like that, hydrogen atom is at the origin. So distance from the origin to hydrogen atom, that is x1 is equal to 0 because it is at the origin itself. Then what about x2? x2 is the distance to the second particle from the origin. So you see, the distance of separation between hydrogen atom and chlorine atom is 1.27 angstrom. That is 1.27 into 10 raised to minus 10 meter. So you see, x2, that is the distance to the chlorine atom from the origin. Hydrogen atom is at the origin. So this distance, which is 1.27 angstrom, that will be the x2, or 1.27 into 10 raised to minus 10 meter is actually x2 here. So you see, we have m1, m2, x1 and x2. We just want to substitute these values to this formula to get the location of center of mass. So you see, the position vector of center of mass is given by this equation, x equals m1 x1 plus m2 x2 divided by m1 plus m2. So by substituting the values, we will get the position of the, or position vector of the center of mass, which is, position coordinate of the center of mass, which is x is equal to m1 into x1. See, m1 is m, x1 is 0. So m into 0 plus m2 x2, m2 is 35.5 m into x2 is 1.27 angstrom, that is 1.27 into 10 raised to minus 10 meter divided by m1 plus m2. You see, m1 is m, m2 is 35.5 m. Then this will be equal to what? M into 0, 0 plus 35.5 m into 1.27 into 10 raised to minus 10 divided by m plus 35.5 m. So that will be equal to what? 36.5 m. So this is equal to 0 plus any value, that value itself. So 35.5 m into 1.27 into 10 raised to minus 10 divided by 36.5 m. So you see this m and this m can be cancelled. Okay, so rest we have 35.5 into 1.27 into 10 raised to minus 10 divided by 36.5. So while you do this calculation, you will get the value as 1.235 into 10 raised to minus 10 meter, or that can be approximated to 1.24 into 10 raised to minus 10. So 10 raised to minus 10 meter is actually angstrom. So we can write it as 1.24 angstrom. That is from the hydrogen atom. You see the center of mass, the position coordinate of center of mass is 1.24 angstrom. That means its center of mass lies at a distance of 1.24 angstrom from the hydrogen atom on the line joining the hydrogen and chlorine atom. So you see the distance from the hydrogen atom to chlorine atom is 1.27 angstrom. So 1.24 will be somewhere here very close to the chlorine atom. So its center of mass lies close to the chlorine atom. Okay, so I hope it is clear to you. Thank you.